Hello, everyone. Welcome to our practice problem webinar. I wanted to introduce a few people before we get started. My name is Karen Bliss. I am the program director for MathWorks Math Modeling Challenge. And we have a couple other people with us. So I work for Society for Industrial and Applied Mathematics, which puts on the challenge. And also working with me at SIAM is Melissa Pascal. And so she'll be keeping us on track and monitoring the chat for us. And then we are also super happy to welcome the author of this practice problem and longtime friend of the challenge, Dr. Christopher Musco. Before we get started, I'll give Chris a chance to introduce himself, but I wanted to kind of give everybody a little bit of overview of the challenge. So MathWorks Math Modeling Challenge is an entirely internet-based contest, so you can do it from wherever you are, and it takes place over a weekend. So there's a 4-day weekend during which you're going to pick a day that you're going to work, and you'll download the question. When you download the question, that starts your 14-hour clock that you'll start working on the problem, and then you have to upload a solution in 14 hours. The questions are always really fun. They're these nice open-ended questions for which you don't have to know any particular type of math. So use the math that you know to answer that. Usually we provide some data, and the question is kept a secret until challenge weekend. So you don't get to know what the question is this year, but you can kind of get a sense for what kinds of questions we ask if you check out our website. So this is one of the webinars where we're going to talk about a practice problem. We do have other webinars, and if you head over to the website, you can find those. But I'm assuming since you found yourself to this webinar that you've seen the other webinars that we have too. And so now maybe I'll give Dr. Musco a chance to introduce himself.
Thanks, Karen. Hi, everyone. Yeah, I'm Chris Musco. I'm been involved in the challenge for a long time because I actually participated in it now almost 20 years ago, in 2008 when I was in high school. And I'm now a professor of computer science at New York University. And my research is on applied math and also its intersection with computer science, specifically theoretical computer science, which is like math for computer science. So yeah, that's what I do for my day to day, but I'm still involved through M through C in that I really like writing problems for the challenge. So I've been involved in like writing previous challenge problems. I wrote this practice problem. Yeah, that's my story.
So you have been involved, and every time we do this, I always think I'm gonna go dig up a picture of you from 2008 so everybody can see
Please
your
don't, please don't.
see your picture when we do this, and I always forget. But you have been involved in the challenge at various levels for a long time. What do you see as some of the really nice benefits of being involved in the challenge
I
for
mean, for
students?
me, yeah, one of the things that I always think of as a big benefit is for me, it opens sort of my worldview onto how I could continue to do math after high school. I loved math in high school, both like doing this challenge or also more traditional math competitions. And I wasn't exposed to this world of applied math, data science. Now the challenge incorporates a lot of machine learning. And these are really mathematical fields. I work in a computer science department, so machine learning is the big buzz right now. And it's the most mathematical part of computer science. So for me, it opened my eyes to ways to continue doing math. I mean, it had a big impact on my career that way because I went to grad school to study applied math, and yeah, now I do research as a full time job and pretty much math every day. So for me, that was the biggest thing, opening my eyes to things, but also just a good way to. Um, it was fun. I liked thinking about real world problems. It was a different way of using math than I did in the classroom or in other math competitions. So even outside of the long term benefits, I thought it was fun when I was in high school.
One of the things I think we talk about a lot with the challenge, which I realized I didn't even mention when I was talking about what the challenge is, We often talk about the scholarship prizes, and if you're interested in those, you should go poke around the website. It doesn't take too long to figure out. We give away more than $100,000 in scholarships every year, and I think that's great. I love that we get to do that, but I actually think the challenge is really good, even if you don't win any scholarship awards. Every year we survey past winners of the challenge to see what they're up to, and we ask them, what did it benefit you in any way to participate? And I was really surprised with the number of people who participated years and years ago who said, when I was in high school, I didn't have a lot on my resume. I mean, you wouldn't, right? You haven't had any big jobs. And if you have had a job, it's probably not, it's not a fancy schmancy job when you're in high school. And they said, so when I was applying for jobs, it was really nice that I got to talk about the challenge, which was an opportunity for me to say, oh, I've had some communication, I've done some communication. I've worked on a team. We got to work under, time pressure, right? Where we only had a limited amount of time. And so people got to say all these really nice things about what they did. And that was whether or not they won. So I think that's one of the really great benefits of being involved, is that it gives you something interesting to talk about on your resume or in college application. So it's a nice benefit too.
Yeah, even like I'm still in touch with a number of students who have done the challenge in the past who I met either at the final event or otherwise. And I'll often like review, say, their grad school application essays. The challenge like almost always features in that because it's an independent project, right? Where you basically did, it's only a day, but you did a full applied data science project. It's exactly the type of work people looking for independent students who can do independent research for grad school are looking for.
Right, and it's not teacher directed, right? It's the first
Yeah,
time that
exactly.
you all
It's
as a
yeah.
team get to come up with what's the directions. That's really cool. All right, we are going to talk about the this. We should move on to talking about this year's actual problem. So I'm going to share my screen and let everybody know where they can find it if they haven't found it already. Okay, so if you found your way to our website, m3challenge.siam.org, there's a million different things I could show you. I'm going to head over here toward resources, and there's something called sample problems. So there's two different types of sample problems. We have all of the past problems posted. So if you want to know what the question was in any past year, all the way back to 2006, those are there. And then if you scroll down just a little bit, you're going to see the practice problems. So we're talking about this one today called Show Us the Money. And there is a second practice problem for this year. So if you go over to the webinars, which again is up here under resources, and look at the webinars, you'll be able to find out when we're going to talk about the second practice problem. But for now, if I click over here to this question that's called Show Us the Money, then we'll be able to read about this question. So maybe now would be a good time, Chris, if you want to tell us like kind of what was the inspiration for writing this question?
Yeah, so we this is part, I mean, a lot of these questions come from things we've been hearing in the news. So uh I feel like there's a problem development committee, it's not just me. And all of us had heard a lot of news stories about sports the cost of sports teams going up. Like there's this famous example of like Ryan Reynolds getting involved in this soccer team in the UK. I'm a fan of car racing, and like there's been huge investment in that over the past 2 years, and team valuations are going insanely high. Another big story has been like the WNBA. Maybe I'm focused on that because like the New York Liberty just won the championship, but I think partly driven by these like star college students coming out, like women's basketball in the U.S. has gotten an insane amount of attention and like big ticket sales, huge media deals. So it feels like every day we're hearing stories about money in sports, all the money in college sports, how college athletes can now make money through endorsement deals. And we wanted to write a question about that. So that's what inspired this question.
Got it. Yeah, I think that's a nice way to think about the challenge too. I feel like now that I've been involved in the challenge for so many years, whenever I'm reading headlines, I am instantly like, that's a good question. That's an interesting question. I wonder
Yeah.
how I would use math and data to solve this one. So
And I think
it's
it's like it's often about like unpeeling. You hear about some phenomenon in the news, like why is that happening now? Like one another thing that was similar to this is how ticket sales for concerts. Like I'm sure people have saw this. The Taylor Swift tour earned like absolutely massive record breaking revenue. And okay, I hear music's great, but why now? Like what changed from her previous tour that now she's making so much more money? So and math, I think math can answer those questions.
that feels particularly relevant. I'm going to share that Chris was headed to Europe and he got bumped off a plane because everybody needed to make the Taylor Swift concert.
Yeah, I mean they gave me a nice chunk of change for that. I'm now a big Taylor Swift fan.
All right. So generally, this question is talking about is talking about sports valuation. Um, what kind of math do you think might be used to solve this one? Or I don't know if we should look at a particular question, maybe, or you tell me what would work for you,
Yeah,
Chris.
we could look at, I mean, we could start with the first one. Like all of these problems, I think you can use a lot of different types of math. Um, yeah, uh, there's this famous article, but I forget the title of it by a mathematician, Giancarlo Rota, who I always recommend this article to like undergrad math students because it has great advice for like a mathematical career. And the one of the main pieces of advice he said is every mathematician only has a few tricks. So like what he means basically is mathematicians often learn some techniques and then they apply them to like many different problems over and over again. I think that model can work well for the challenge. So like it's best to try to use what you know well rather than try to like use something you don't know super well. So like if you're comfortable with, you know, arithmetic algebra, try to incorporate that into the problem. If you've done some linear regression in your class, try to incorporate that into the problem. Use something you know how to apply well is often more important than finding exactly the right technique. Um,
I
for the
would echo
first
that.
problem, yeah, go ahead.
Cut you off. I would echo that and say that when I hear back from judges every year, so the students are going to work on math using math and data to answer these questions. But at some point, they've got to write, right? So at some point, you've got to write up your solution. And that is the artifact that judges are going to see. And that's how they're going to understand what your math is the piece that you've written about. And so I hear from judges every year that the writing is usually much better if students do it seems to be better if students have a really deep understanding of the math that they're using. So if they're using something that they don't fully understand, they're like, I don't know what this is exactly. I tried it and I think it did something and here's my results. That's not as strong as saying, hey, I understand this tool and I know how it works and here's how it works and here's how it worked for this specific example. That it's usually the examples of writing that's really good that leads to a strong solution paper. So I would echo that it's good to use the math that you know. That makes a lot of sense to me. Okay, so I'm going to go ahead and read question one.
Yeah.
So question one says, like any business, a team's value is tied to how much revenue, i.e. income, is generated through ticket sales, television, streaming deals, stadium concessions, other sources. For your chosen team, and there were some options, for your chosen team, create a mathematical model to project how much revenue the team will bring in over the next 10 years. You may wish to consider historic performance of the team or comparable teams, as well as global trends in revenue numbers across sports. Okay, so that's the idea, is predicting revenue for a team and not focusing on anything else, just focus for a minute on revenue. So how do you think you might go about answering such a question?
I think there are a lot of ways to approach this one. I think if I was to do this, so it's asking you to predict revenue over 10 years. So how much is the team going to earn in 2025, 2026, all the way through 2035? Um, I'd probably start by trying to predict revenue for just for this year, 2025. And then a naive model is you just multiply that by 10. That's revenue for the next 10 years. it might be that you think revenue is going to go up, so you can imagine more complicated things. But if you just start with 1 year, I think that makes a lot of sense. And for 1 year, this problem's really about it's an addition problem. You just got to figure out all the pieces, right? Like how much did you make from tickets? Plus, how much did you make from TV deals? Plus, how much do you make? Often, sports leagues pay the team some amount of money because of what they get for TV deals. How much did you make from concessions or merchandise? This sort of stuff. So it's really about finding each of those numbers, and then hopefully it's a relatively simple model from that. You sum them together. But the trick is it's not going to always be easy to find those numbers. So for some teams, you'll be able to get some of that information, but for other teams, you won't. So you have to think about like what mathematical models can I use to sort of fill in the gaps of my knowledge. So for example, suppose you're trying to add up how much does a team make on uh, like merchandise, like it sells maybe T-shirts and hats and jerseys and this sort of stuff. If you don't know that for your team, can you find some data online that says like what is the average amount of merchandise, say a team in the league sales a team in the league makes? Or maybe you could find how much merchandise did another team sell, like and try to use that as a baseline number and maybe adjust it for your team. So maybe your team, like one thing we talk a lot about with sports is market size. How many, like teams in New York are considered big market. That's where I'm based out of, are big market teams because there's a lot of people watch those teams. Teams in other areas might be smaller market teams. Like they hit a smaller population. So maybe you would adjust your revenue based on a population difference. That's probably where I would start. And then you can start thinking about like change over time, right? And there's also a lot of ways to do that. Like we see a lot of students do linear regressions. Oh, I can maybe get some data on ticket sales over time that I can project that into the future by fitting a line to those data points and then traveling along the line. That's one way to do it. There are other ways. Maybe you could say, oh, ticket sales, you get some numbers, have been going up on average 5% a year. So I will predict that they will continue to go up on average 5% a year. And then you can use even more complicated models. Like we see some teams use logistic growth models. Uh, so yeah, a lot of different options there. But I view this one as like first start with 1 year. Your year takes the inputs and then figure out how those inputs will change over time.
That makes a lot of sense. I didn't mention this earlier, but I am interested in hearing from all of you. So do you guys have questions for Chris? How might, or,
Or different
you could,
ideas, because there's a million ways to solve these type of problems too.
yeah, what ideas do you have? And maybe we can banter those, like chit chat about those. Like, does that idea make sense? What might that look like if we brought that into the question? So if you would want to type your ideas in the chat, that would be awesome. And then we can look over there and talk about your ideas too. And maybe while people are doing that, maybe it's a good time to ask. So I hear you saying, so you're going to go look for some data. You might not be able to find some data. How does one go about looking for data?
Yeah, this is a challenging part of the challenge because you can always spend more time finding better data. So there's really like a time trade-off. Like, do I invest time to get better data? But at some point, you just have to start doing your modeling and getting results. I mean, so yeah, I think it's important to balance the time. Google's your friend here. If you search for like data sets on X, you will often find them via Google. One thing I often do is I'll actually do Google image search because on Google image search, you'll see summary plots of like data sets. It lets me more visual quickly check, does that have data that I need, than looking through like the text results. So that's one recommendation. Um, yeah, there are other sites like Statista that compile data sets, but they'll be indexed by Google. So I start with just a general search engine. We also give students data for the challenge. So we do this less for the practice problems, but because you guys aren't under a 14-hour time crunch. For the challenge, you have a data set. We have given you data that we believe is sufficient to solve the problem. A lot of students will bring in their own additional data that is tailored to their modeling approach, but a totally valid option is to not look at any data beyond what we give you, and it should be enough to get a reasonable solution to the problem.
A little peek behind the scenes. You guys are working on data collection right now for this year's challenge. Do you want to tell us what this year's challenge question is going to be? Just kidding. You're not allowed to
Yeah.
tell.
Okay. Oh my God. I was like, is she trying to give a bonus to the people who showed up for the webinar? Yeah.
You don't get to know. Yeah, so they've been working really hard on trying to get the right data. I think that, yeah, I think that's something that everybody should understand is that we have actually tried to get the right data. And if you're thinking, oh, I really, in order to answer this question, I sure wish I had data that was these two, what's the relationship between these two factors? Probably they thought of it and they couldn't find it. So you're welcome. And we've done this before and we couldn't find the right data and we did have some teams find the right data. So I'm not saying don't look
Yeah.
for it. You could look for it. That's happened. But if you're coming up short, so did we. And that's why it's a good question, right? That's why it's a hard question because we didn't find exactly the right data to be able to answer this. So we have to try and sort of do some of the approximation like, well, I don't have the data for this exact scenario, but I have it over here. And here's how I think I would translate. So those are really great things. Those are great things to talk through in your paper about, hey, I didn't have this data that I wish I had. And so I use this. Those are exactly the sorts of things that judges are going to love talking about. There
Yeah, the
is a
other thing that's important is important to remember the data is usually an input to a model. So it's perfectly valid to have a model that says, ideally, our model would use the previous 5 years revenue for the team. Because we didn't have that, we use the average revenue for teams in the league. But if we were to deploy this model in the real world, we would just ask the team for that data. So like that is a fine thing to do on the challenge, where you use the best proxy you have, understanding that it could be improved if you had more time.
right, right. Those are all good things to talk about. Let the judges know that you've done this because this is what I had with the constraints that I had, the time constraints with the data constraints. This is what I've
Yeah,
done now. But here's what I would love to do if I had more time and more resources. Great things to
yeah.
talk about in your paper. We do have a question from Mulik, and I hope
Oh, I
I
didn't see
pronounced that
that on
correctly.
the. Wait, it's in the
It
chat.
says, yes. Oh, maybe it's
Oh,
just
I
to me.
don't see it.
That's all
Okay.
right. Would the judges mark higher if we take into consideration more factors? What do you think?
Yeah, this is a good question. I think it's a balance. It's one of these things where like we see teams try to do too much, and then if they don't do each individual part well, that detracts from the judging. Because the biggest thing with judging is they want to understand your model and think each piece of it was well justified. If you throw in a ton of different factors, you open yourself up to a critique of saying like, oh, they didn't do that one particularly well. So I think it's a balance. Like I think you sort of want to do incorporate as many factors as you can that you can do well in the time given. The other thing is you can always hint at how you would it's we like when we see extensible models. So it's nice to say, okay, like for this problem, you could say we modeled only ticket sales and television deals. And we did that by creating like trend lines that projected how much these are going to go up out into the future. One thing that's nice about our model is given sufficient time, it could also be applied to merchandise sales or sponsorship deals. So like it's again like models that will generalize to more factors. We'd rather see you just say that and do it well than
Well, then.
yeah do a poor job on too many factors.
It's a question of balance for sure. I will say that if you have time, that it can be good to say we started with two factors. This is what Chris was. We started with two, and so for instance, in the challenge, we typically have three parts, right? So and we do in this practice problem as well. There's three parts to the question. So you probably want to make sure that you have a solution for all three parts.
Right.
If you don't get a solution for all three parts, you should submit it anyway because you might end up surprised. But go so I would start with something simpler. And then if you end up in the enviable position of having answered all three questions and all of that, then you can always go back. And it's okay to answer question one a couple times. if you will, right? To say we
Mhm.
started with just these two factors that we thought were the most important. And here's what we came up with this for a solution. And then we decided to add in another factor, and here's what the solution looked like there. And we wouldn't be done, right? Like we could continue doing this and add in, and here's the next factor that we think is the most important. And so it is possible to even include a revision to your model. But there's nothing wrong with starting simple. Like there's an advantage to a simple model that everyone can understand. That's actually a good thing too, right? So,
Actually, I wanted to add something onto that because we've been seeing students have been doing this more and more in recent years, and didn't expect students to do this, but it's really smart and it's what people do in the real world. There's a benefit if people do mathematical modeling in the real world, like they they typically start with a really simple model because it also gives them a sanity check for their more complicated model. So, say you're trying to predict revenue. One very simple way of predicting revenue is you look up what was this team's revenue last year and you multiply by 10. This is going to give you a baseline number. Like, okay, maybe it's $1 billion. If then your more complicated model tells you they're going to make $100 billion, you should see that maybe something's wrong, right? Like, there's too much discrepancy there. So we actually really like when students put down a simple model that then they refine later because it can help in judging the more complicated model.
great point. Great point. Okay. Let's move on to question 2 here that's called priced out. So I'm going to read it first. For most teams, it's easy to find values listed in various sources. In fact, many of the articles that are linked here contain such values. However, these numbers are simply someone else's best guess. Come up with your own model for valuing the team and report your best guess for its current value. Another way to think about this question is, if the team was sold to a new owner tomorrow, what price do you think it would sell for? Your model might take into account your solution to question 1, as well as other factors like prices recently commanded by similar teams. All right. Maybe before you get started, Chris,
Yeah,
I would
yeah.
ask everybody maybe to pop in the chat, if you will. Doesn't have to be what's your whole model, but what is something that you think you would want to incorporate in a model to answer this question? So what would be important? Certainly you're going to use your answer to question 1, but what else would be good for you to be able to have as part of a mathematical equation, formula, or something like that? What else would we want to include in there so that we could figure out a good estimate of what the team is worth today? I'll give you a minute. Every answer is a good answer, I can tell you that much. Thanks, Drew. I see yours. Very nice, Malik. I see. All right. I don't want to. Oh, here we go. Finley's got an answer. All right. So hopefully everybody can see those. Thank you, Kevin. Excellent. So we have a lot of different options.
Hmm.
And yeah. So I don't know if you can see those too.
I can
Drew
see
would
them,
say,
yeah.
yeah, other league and their recent sales, not just revenue, but profit, right? That's a difference. Not just how much money are we taking in, but how much money does it take to upkeep the team?
Hmm.
Average price of teams in that field, players, individual prices. I think that makes a big difference. Length of contracts, that's probably something that would be important to think about. League level and team level multi-year trends in viewership and ticket sales. Awesome.
Hmm.
Um, so I'm going to let you tell us maybe, Chris, some potential avenues that you think about for this model. I got to say, to me, when I'm reading this one, um, it, it, I feel like I have an easier time thinking about projecting things out into time and thinking about watching
Hmm.
trends time. And so this one, where we're just focused on what's the value today, What does that look like in terms of like a mathematical model? Because I always think there's a graph and I'm seeing what that function looks like somehow. Uh, how would you tackle this from like a math modeling perspective?
I mean, I again, there's always like a million ways to do it. I like the suggestion that Drew is bringing up, which using data of other teams in the league and their recent sales, because uh, sports teams are complicated. So like it's hard to sort of get at their value from fundamentals. So it's often this is an approach that people use in other areas. People call this using comparables. So like when people price homes, that's actually what they almost always what they're doing. Like you can try to price a home based on its square footage, recent upgrades, and they do a little bit of adjustment on that. But usually mostly when people price homes, they come up with like the 10 most similar homes that have sold in the area, and then they take the average of those and they make that the starting point for the price and then maybe adjust it a little bit. So like I like this idea that Drew's coming up with. And then there's a lot of that can be done on top of that. So for example, if you have a small market team, it's not going to be worth the same as the Dallas Cowboys, even if Dallas Cowboys sold yesterday. So I think an important thing if you're going to do one of these comparable models is to figure out what's the right way of like measuring similarity between teams. Maybe I do a weighted average that includes the value, the sale price of more similar teams higher. So there can be a lot gone into one of those models, and that's not really doing any time series prediction at all. It would just be looking at some recent comparables and making some choices for how you decide what teams are similar, and hopefully doing that in a formal way, not just like an eyeball way. Um, yeah, so I really like that approach. I also think Malik and Finley are bringing up two like interesting points. I'm not like 100. Finley, were you? I don't know if you can expand on it in the chat or you can also speak out. When you were thinking about player contracts and prices, were you thinking this is could maybe decrease the value of the team because it those are costs you have to pay into the future, or were you thinking maybe it could increase the value of the team because if you sign like Lionel Messi to like a really long contract, your team suddenly gets more valuable. I guess it could go either way.
Finley, you're welcome to unmute. If you do, you're going to end up being on
Yeah,
the.
you can either unmute or you
Otherwise,
can type in chat.
type in the chat. We'd love to know what you were thinking. Yeah, I could see that from both perspectives, right? So
I guess
having a
where I was going is
player,
like both Finleys and Malik are getting at there are costs to running a team. It's not just revenue. And so I think one way you could approach the problem is putting that piece in from part one. So part one just is how much money is going to team earn. Then you can try to figure out and what does it cost to run the team, and hopefully get some number for like what's the yearly profit that a team makes. And then if you can figure out the yearly profit that a team makes, there are like methods for then getting a value for the team. So often people do this in like the business world. Like, what is a startup worth? What is this new company worth? They'll often look at its earnings minus its fixed costs and then try to do some multiplier on that. So you'd say like, oh, like a tech company is worth 10 times the profit it can make each year. So that is also like that would be a totally different approach, not doing comparables to get trying to get the value of the team. Like figure out how much money it can make each year and then do some multiplier of that. Um, but as Finley and Kevin are pointing out, to do that, you need to figure out what it costs to run the team.
so interestingly, I can tell you where my brain, oh, there we go. I'll
It applies to
stop
both scenarios. They're good players and it may increase profit.
increase.
Yeah, this is true. Yeah. Um, One thing is it's hard to make this stuff that, yeah. So I think you were thinking of both sides basically, right? Like if you have these costs, that reduce value, but if you have good players, yeah. One thing you could imagine, I mean, it'd be interesting to think of how you could mathematically incorporate the fact that a team has a star player on a long contract. Um, I would have to think about the best way to do that. Yeah, oh, Kevin just said the same thing. There's significant value for brand, which star players can build increased value. So maybe you'd have, I don't know the right way to incorporate that, but maybe you'd have like a multiplier that took into account star value. And that might be the type of thing where it becomes a less mathematical part of the model, right? Where there's like a math part and then you assign a multiplier score that says like if you have a star player. Or maybe you guys can think of better ways to formalize that than I can. But I think that would be really cool to
And it
know.
would be interesting in order to figure out what should that multiplier be or how big of an effect does it have.
Yeah.
Applying it to a team that has recently sold and trying to think about like what would it have taken to come up with the valuation that it did sell for. So that's sort of an interesting way to think about this problem too, is like in order for me to know this unknown quantity, let me go try and apply it to these sort of known scenarios. Yeah.
hmm I mean, that's a really good point. Kevin just said it might already appear in historic revenue trends. Right. So like after, yeah, Kansas City won their first like Super Bowl with Patrick Mahomes, like you probably saw a jump in revenue. Maybe you could that could give you a sense of like how much having a star player increases the revenue or potential value of a team. That's a good point.
hmm
Yeah, good point.
Um,
And Aryan's saying the exact same thing. Yeah, agree. Okay, so maybe that'd be the form. Maybe then you guys answer my question. That's the form. Good way to get a multiplier. Look at it's sort of a comparables approach. Look at teams
yeah.
in the past which have then signed a star player. See how much that increased their revenue. Hopefully, that's data you can find, and then use that to adjust for a team that has recently signed a star player. Yeah, that's
It
cool.
was like teamwork. We're coming to some consensus.
Yeah.
Oh, nice to see you, Kevin. Okay, so I was going to say that interestingly enough, my brain went to somehow that like win and loss should be accounted for in
Mm.
this. That if
Yeah, yeah.
some team is on a winning streak, and I am hearing from everyone else that that probably has, I don't know, a lesser effect. It's funny that that nobody's brought that one up because I just thought, oh, that's the obvious one. Are they
No,
doing
no,
well?
I think that's a good one. I think we just didn't think of it, right? Like
Yeah,
your recent if you were a successful team, you should have higher value. So
yeah.
you in turn like I think it's along the same lines if you have a star player, you should have higher value. So maybe there'd be some way of incorporating the recent win record because that
Right.
tells you the if you've been winning a lot recently, it maybe says you're more likely to win a championship. And that always brings like sponsorship money and
Million dollars.
endorsements and yeah,
Sure.
lots of more viewership. So that's a great idea, Karen, I think.
Okay, so it sounds like Arian is asking, would something like this be given or would it be external research? And I think, do you mean the ideas here or the data? Or yeah, I guess sort of this like which are the factors that should be included? Do we usually give those to teams?
I think we suggest some. I mean, it's maybe I assume you're asking about data. Yeah, so that
Could
would
be.
not have been included because I didn't think about that until you guys brought it up. So unless someone else on our problem development committee thought of it, so this is exactly the example of like a case where it might be worth the students' time finding some data because uh, we can only we can only predict the approaches students are going to take to some point. I hadn't really thought of this like star player and multiplier thing. So probably I wouldn't have collected data for that. But hopefully that's the type of thing that would be reasonable for you to collect um, in a short
Yeah.
amount of time. Yeah.
Okay. Before I move on to question three, I kind of wanted to step back and ask a little bit more general question. So there are typically three parts to the challenge. And
hmm
I'm wondering if you're a team, should you think about spending equal amount of time on each one? Or what's your perspective from an author's perspective about how these three parts, do they always fit together? Should we, yeah, I don't know. What are your thoughts on that?
I think there's yeah, it's a so usually part two is like the meatiest question. Part one is usually also involves a lot of modeling, but is maybe usually slightly easier than part two. Part three is always the most open-ended question. I think in an ideal world, we want students to be able to invest time in all parts, but we recognize that this is hard. So like I think most teams like spend enough time on problem one to do it as well as they can, and then put a lot of time, their remaining time into part two. And if they can do that successfully, they do the best they can on part three. We want you to get an answer for all questions, but we understand realistically, like often teams have less time for part three. Um, yeah, although it's like a, I don't know, it's hard to give advice on this stuff because if you're trying to win, a part three solution that stands out can often really set a team apart because just because a lot of teams don't have time to do a good job on it, if you can have like a really unique or interesting or complete part three solution, that often stands out to judges just because a lot of teams didn't make it to that part. So yeah, I don't know if that's a good answer, Karen. It's hard to say, I guess.
It is. It's hard to
Yeah.
say. I
We do
think.
like model reuse. So we do like when you use stuff from previous parts to carry through the rest of the models, just because first off, it's a time saver. It shows you're thinking about the question on like a global scale. So that's always nice to see, but certainly not required.
Yeah. So how does one model fit into the next part of the question is if you can find a way to link them. It is not always the case that you'll be able to use the question one model and question two. But at some point, probably when you're answering question three, there's usually a way to link either question one or question two or both in answering
Yeah,
question. Usually
yeah.
that's the so developing a model in part one that will help you also will serve you well in part three typically.
So
And
Aryan asked a question about this. Is it better to partially answer all parts or full answer one part? Yeah, I we always okay, I don't know. It's like if you're going for there's you can optimize your time in different ways. If you're just doing the challenge because you enjoy it and you want to dig deep on one part, you should feel free to do that. If you're really going for the win, like you're trying to get to the final competition, earn some scholarship money, you should try to get an answer for all three parts, at least something down. Uh, and that often requires being pretty thoughtful about how you coordinate the team, right? Like make sure you have like a clear lead assigned to each part. Some structure in the team of okay, like we're at the first 15 minutes, we're gonna divvy up who does which parts of the question. So like doing your team management to delegate tasks is important to make sure that gets done. Yeah, exactly.
right,
You said it, RM. Yeah.
delegating tasks. I noticed earlier Melissa put in the chat a link to the score guide. And it's just sort of a general scoring guide for the challenge. But you'll notice that there's certain percentages for each part of the question. And so that could maybe give you a sense of how much time or how much effort to put in each parts of the question. However, you should notice that there is a part that is that's related to discretion. So judges can read a paper and think this team knocked it out of the park on question one. Question two, they did a solid question two, and question three was, like pretty good. They came up with an answer, and they also acknowledged that if they had more time, they would do this and that. But they can assign sort of more, like a higher percentage, because of those that discretionary section where they're like, you know what, I still think this is an outstanding paper because what they did in question one was so amazing. And then that paper can move forward through judging purely based on that, like you did a really amazing job on one or two parts. Even if you didn't do an amazing job on a third part, if you came up with something and then said, if I had more time, I would, then
Hmm.
that paper can move on. And I find a lot of discussion when we're really getting down to the wire and trying to pick out which are going to be the top papers about. Well, this one did a really amazing job with question two. This one did a really amazing job with question three. And how do I balance these? And it's hard to decide. But all of those conversations are happening with like acknowledging that no one has any perfect solutions. So in general, even if you haven't fully answered something, I would go ahead and submit it because you never know. Like the
Yeah,
judges are
for sure. Yeah.
love
We
particular.
actually had one of like the technical computing awardees last year did not answer question three, which is unusual.
Yeah,
But it was they had just done such an amazing job on the first two questions. So yeah, certainly submit no matter what, even if you don't get to one of the questions.
that is good to know. Super good to know. All right, I'm going to read this last part. So question three here is, suppose an investor or a new owner acquires your chosen team and wants to invest money into the team to increase its value. For example, they might want to invest in a new stadium, a new star player, marketing efforts to increase the fan base, or something else. Create a mathematical model to evaluate the impact of at least one possible investment option on the team's revenue and long-term value. Okay, so there's a lot going on in there. We're getting a mathematical model or maybe models that are going to evaluate the impact of one of these investment options on revenue and long-term value. All right. Any ideas on where you might get started on this one, Chris?
Yeah, I keep saying it. There's like a lot of options. I mean, so this ties into both. Basically, this question's asking like, if you make a change to the team, how are your answers to part one and part two going to change? So one, like the first example I gave there was you might invest in a new stadium, and what I had in my mind there was uh, if you have a bigger stadium, you can sell more tickets, and if you have like a nicer stadium, it also just might entice more people to go to the games. So yeah, one thing there would be figuring out like, okay, if I increase the size of my stadium, my ticket sales have the potential to go up by X%. But then there's also a cost associated with building the new stadium. So that could be one model, right? Try to figure out like how is the revenue going to change? Ideally, it will just increase. And then if in part two you did something along the lines of what like Kevin and Finley were suggesting, where you're accounting for costs, how's the cost going to change? So then that could get incorporated into a part two model. Um, so yeah, the really big thing here is like your models for part one and part two have inputs. And this question is asking like how will those inputs change if you make a change to the team? Um,
So this is a great example of one of those questions where we're going to use the models developed in questions 1 and question 2 to try and help
yeah.
answer this bigger question in question 3, right? So everybody's trying to increase the value of their team, and so how, yeah, what's the right lever to take on this? Um,
And then related to like the marketing and like star power, we like this is I guess a bit related to what we were discussing in the previous question. Like I was the WNBA, the Women's National Basketball Association, is one team I had in mind. So like we've seen a couple star players come out of college, like Caitlin Clark and Angel Reese, that are like vastly increasing viewership. So one thing we had in mind is you could say like, okay, if I was going to buy a WNBA team, maybe that should be high priority because there's a huge following for women's college basketball. Can I sign a star player coming out in the next year and get a similar bump to my ticket sales? So again, this might be a more comparables approach. Like look at how ticket sales for teams that have signed star college basketball players have gone up by.
Very cool. If you were a judge for this third part of the question, what do you
Hmm.
think might make something really stand out? Like what would make a solution stand out in this third part?
I mean, that's a good question. Often the solutions for part three stand out because they're doing. We try to ask more open-ended questions, and often they stand out because a student just thinks, or it's a student team thinks of, an approach that no one else thought of. Like for this question, probably part one is going to look relatively similar. Everyone's part one. I'm not exactly the same, right? But you're trying to come up with ways of estimating these inputs that affect your revenue. It's going to be sort of similar. Part two, we already thought of two different approaches, right? Comparables, or you could try to like do some multiplier on top of profit. So it'll be less similar, but I don't, But part three, we usually see a huge range of different solutions. So we like stuff that comes off as like creative or new. So maybe you can think of like a way to uh, market a team, like to increase the revenue of a team that's unique that we didn't think of in the question. That would definitely make it stand out. I don't know if anyone has any ideas. I mean, if you suddenly became a billionaire overnight and you could buy a sports team, does anyone have any clever ideas for what you would do to increase the revenue of that team? Well, maybe we'll leave that open ended. But yeah, I think for part three, uniqueness also stands out, often stands out.
I think that's true. I agree with that. Okay, well, um, I think we have a few minutes left, and I don't know if anybody has general questions about the challenge, any more questions about answering this particular problem? Anything you would want to ask Chris about what it was like for, for him as a participant? Anything? We're opening the floor. Stop sharing this. Is everybody registered for the challenge? Hopefully you're registered by now. We're super excited about this year's challenge question. And say that much without saying what it is.
How was it for crispy participant? What was the actual experience like? I mean, I really enjoyed the experience. So when I did it, the question was about ethanol, which now is like all the students participating don't even know about this conversation. But like when I was in high school, a big conversation was the U.S. was going to get energy independence by switching from gasoline to like ethanol powered vehicles, which is a fuel derived from corn. And the question was like, is this a economically viable possibility? Which it was really interesting because it was a very timely question at the time. Um, when I was a participant, the experience was quite different because no one had laptops. So we all packed up our like ridiculously heavy desktop computers and monitors and like drove them to one of our friends' houses and like had to set them up in like different rooms of the house. And also, we didn't have internet for all the computers because we didn't have Wi-Fi on all the computers. So it was like a totally different experience in terms of like pre-internet age, but it was a ton of fun. Like I love the experience of being in a in a place with four people I was friends with for like an extended amount of time working on one problem. I really enjoyed it. How old was I? I guess I was a senior, so I think I was 17.
Right?
We
Yeah,
didn't know about the challenge until I was a senior, and then my math teacher found out about it. We did it, but then actually the students who were younger than me, I think, did it for a couple years after, at least a couple years after that.
right, right.
This was also my first time really writing like a research paper, which is funny because now that's my full-time job. But like I think I had never done, you write research papers in high school that are of the flavor like, oh, you learn about a topic by reading about it and then you digest that information and put it in a paper. But this is the first time I wrote a paper where we came up with the ideas, and then we had to justify those ideas to the reader and explain the ideas. That's now what I like. My whole job is basically coming up with new research ideas and justifying. It's very different. So I enjoyed that. That was a new experience for me. And
That
you
feels
expect
really
it, yeah.
relevant
Oh,
to the
good.
workplace, actually, right? I
Yeah.
mean, in a lot of workplaces, it's going to be that if if you have a job and you're tasked with getting something done, you're going to need to defend the way that you're going to do it, right? You're going to say, "Hey, this is my plan for getting the job done," and they're going to say, "Oh, you don't want to do it that way, do it this way," and you're going to be like, "No, I've thought it through. These are the things that I think we should be doing, and here's my projections for how it's going to turn out." And then, yeah, that can be very workplace relevant. So that feels like something that could be very useful to come out of this. Sorry, there's more questions. Can
So
we
one was,
expect
can we, yeah, go ahead.
to be related to current events? Finley's asking that. In general, we do. I am forever sending the problem development committee articles that I see in the news of like, how about this as a topic? How about this as a topic? Can you guys turn this into a question? And so I think without giving anything away, I could say that this year's question is going to be, yeah, relevant.
Yeah, either current events or current trends. It's almost always, yeah, we're trying to pick stuff that's going to be relevant for the future. Oh, Malik has an interesting question. Your friends,
Mm,
team members, how much effort was put into getting them to do work and not just mess around? Yeah, this is a challenge. I mean, yeah, we struggled with this. I think all teams struggle with this. I think like having some structure for the team might be important. So we were a math team, so we had already done competitions together that were more like traditional math competitions. So I was already like the captain of our math team. If you don't have some sort of like I guess power structure for lack of a better word. It might be worth thinking about like assigning some roles ahead of time. Like this is going to be like the captain. This is going to be like the problem one lead, the problem two lead, and problem three lead. Because if you give people responsibilities, like you are leading problem two, I found that that tends to make them less likely to goof around and not be on task for the problem. So that's one thing you could try, but it's a challenge, yeah.
the challenge inside the challenge. We
Yeah.
do recommend for what it's worth, like identifying someone to be the team leader before we start. And I
Yeah,
think delegating and giving people specific jobs is super important. I also would say the challenge is 14 hours long, but we don't expect for people to be sitting at their computers for 14
right.
hours, like head down, working, like just grinding it out for 14 solid hours. That would be exhausting. Everyone has permission to take a break. Like,
Yeah, yeah,
take a
yeah, that's
break
right.
and give yourself like time to, so hopefully if you're building that in, maybe you can say carve out that time and say, all right, everybody, we're going to work for an hour, then we're going to take a 5 minute break and take a little walk or get something to eat or, whatever the case may be. But if you build that in, maybe that helps a little bit.
Yeah, that's a good idea, or like a built-in lunch break. I also
Mhm.
feel like sometimes people goof around because they're just like literally physically antsy. No one can sit for 14 hours on work. So one thing I've seen, we didn't do this, but one thing I see now because the students send photos of when they did the challenge is a lot of people use whiteboards either because they do the challenge in a classroom or they get one of these like inexpensive whiteboards you can get on Amazon that just like tapes to your wall. That's nice. You can stand up, you can like draw at the whiteboard. It like, it just gets people up and about, moving around, which can be helpful.
And it can help if, especially in that brainstorming part about trying to think about all the different aspects together,
Yeah.
kind of like what we were doing. It would be nice to be able to write them all down and see them visually on the board and think about maybe, just seeing them would spawn more ideas even. So that could be super helpful too. Yeah. Alrighty. Well, I think we should probably wrap up. Thank you all for joining us today, and I look forward to having you all participate. If you have any questions, please feel free to reach out to us. I'm happy to try and answer your questions and um, point you toward the right resources that we have on our website. Please join us for our future webinars. I think we have another one coming up next week, maybe that's about MATLAB specific. So feel free to join that one. And we'll have another practice problem in a few weeks as well. I do want to say thank you to Dr. Musko. This was super helpful and I really appreciate your thoughts. Thanks for coming.
It was great. Thank you guys all for the great questions and suggestions.
Great.
And thanks
Okay.
for hosting, Karen.
Yeah. Thanks. Let us know if you need anything. Bye.
Bye.